In 2018, Florida wildlife officials did something that looked completely reckless. They rounded up 328 beavers from overpopulated areas and dropped them onto 15,000 acres of barren land in the Panhandle. No trees, no vegetation, just cracked, dead earth drained for agriculture decades earlier and abandoned when the soil turned toxic. Environmental organizations called it a waste of money. Biologists predicted the beavers would starve or leave within weeks. Local ranchers said the animals would destroy whatever land value remained. Everyone agreed it would fail. 6 years later, those 15,000 acres are unrecognizable. What happened there is now considered the most successful ecological restoration project in Florida's history. This is the story of how an animal that cannot survive without trees turned a dead landscape into a thriving wetland, and why scientists across the world are replicating the approach. Here is what this land actually looked like in 2018. The site sits in Florida's Panhandle, near the Apalachicola River. Back in the 1950s, it was untouched wetland, cypress swamps, hardwood forests, winding streams loaded with fish. Then agricultural corporations moved in, dug a network of drainage ditches across the whole area, and planted crops. The drainage did its job too aggressively. The water table fell 15 feet. The organic-rich wetland soil dried out, oxidized, shed decades' worth of stored carbon, and turned acidic. The crops gave out after roughly 20 years, because the soil had nothing left to give. The companies abandoned the land in the 1980s and never came back. You could walk the entire property and not find a single tree. The drainage ditches had sliced the land into rigid geometric blocks. The surface was hard-packed clay, blended with dead organic residue. When it rained, water streaked through the ditches and emptied into the river without ever penetrating the ground. When it dried out, the land turned to powder. Only sparse invasive grasses managed to take hold. No birds used it for nesting. No amphibians bred there. Field surveys found wildlife populations at essentially zero. The state of Florida held title to 14,782 acres that drained money to maintain and generated nothing in return. Conventional restoration looked financially impossible. Reflooding the site would require constructing costly water control infrastructure and then waiting decades for plant life to re-establish on its own. Estimates put the price at $87 million over 30 years, with no guarantee it would actually work. Then someone floated a different idea entirely. Let the beavers handle it. Dr. Sarah Martinez, a restoration ecologist with Florida Fish and Wildlife, put forward a proposal that read like deliberate ecological self-sabotage. Take beavers, animals that depend on trees for food and construction material, and turn them loose on land with no trees whatsoever. Give them nothing. Let them work it out. Her logic came from beaver behavioral studies conducted in the 1990s. When beavers cannot locate trees, they do not collapse and die. They adjust. They construct dams from whatever they can find. Clumps of grass, sticks scavenged from long distances, invasive plant material. Those dams hold water back. Held water lets vegetation root. Rooted vegetation feeds the beavers. The beavers then enlarge their dams and push the wetland further outward. The real insight Martinez brought to the table was that beavers are not simply dam builders, they are ecosystem engineers. A single beaver family does not just transform one patch of ground. Their activity sends ripple effects across entire watersheds. Release enough of them at carefully chosen points, and they build a network of interconnected wetlands that sustains itself without human assistance. The plan was to trap beavers from overpopulated zones, where they were already flooding roads and agricultural land, transport them to the dead site, and release them without any supplemental feeding or artificial water supply. Just set them loose and observe. The total budget was $680,000, most of it covering trapping, transport, and 2 years of monitoring. Against an $87 million conventional restoration plan, it was nearly nothing. But nearly everyone was confident it would collapse. Florida approved the project in April 2018. By August, 328 beavers had been distributed across 47 release locations, spread throughout the 15,000 acres. Then the waiting began. For the first 3 months, every critic looked prophetic. Aerial surveys in September 2018 showed that close to 40% of the beavers had already left their release zones. Trail cameras recorded animals wandering aimlessly, clearly searching for somewhere more hospitable. Several were found dead, most likely from heat exhaustion or starvation. The beavers that stayed did attempt to build dams, but the results were dismal. Crude mounds of mud and grass, barely 2 feet tall, sitting in the drainage ditches. Most washed out within days when water moved through. The ones that held created shallow puddles 30 feet across that dried up within a week. By October 2018, environmental groups were formally demanding the project be terminated, arguing it amounted to cruelty toward animals placed on land that could not support them. Local news coverage treated it as another government project burning through public money for nothing. Martinez and her colleagues were taking serious heat at public meetings. Then something started shifting that no one had anticipated. November 2018 through February 2019 was the dry season in Florida. This was the window in which the project should have folded completely. No rainfall means no water, and beavers need water to function. But the trail cameras began capturing behavior no one expected. The beavers had stopped building dams in the drainage ditches. They had figured out that water moved too quickly through those channels to be held back. Instead, they were constructing dams at natural low points between the ditches, spots where rainwater pooled on its own when storms came through. The dams were modest, 3 or 4 feet at most, but their positioning was precise. Every drop of rainfall that reached those sites was being caught and retained. When a significant rainstorm arrived in December 2018, the effect was immediate. Water that would have run straight into the river, instead, backed up behind those small dams. Puddles that were 30 feet across in October had grown to 200 feet across by January. They were not evaporating because the dams were holding water at depth rather than letting it spread thin. That standing water triggered something dormant in the ground beneath it. Seeds from the original wetland vegetation, seeds that had been waiting in the soil for decades, began to germinate. By February 2019, survey teams were finding wetland plants establishing themselves around the beaver ponds, sedges, rushes, a scattering of willow saplings. The beavers began feeding on them immediately, but selectively. They harvested some plants for food and building material, while leaving others untouched. The ones they left continued growing. The ones they cut back regrew from their root systems. Wetland plants are built for that kind of repeated disturbance. By March 2019, 8 months after the initial release, the surviving beaver population had steadied at around 215 individuals, organized into 47 family groups, each holding its own dam site. And those dams were starting to actually perform. Spring 2019 brought heavy rain, and the results were dramatic. The 47 dams across the site trapped volumes of water that previously would have drained away entirely. Ponds that had measured a few hundred feet across expanded to quarter-mile wide wetlands behind the largest structures. The beavers kept adding to their dams, raising heights and extending widths. A 3-foot dam from January had become a 7-foot dam by May. Where multiple dams sat close together, the ponds behind them merged as water rose and spread. The largest structure, built by what researchers labeled the Alpha Colony, stretched 450 feet across and created a 14-acre pond behind it. That single 14-acre pond changed the surrounding landscape. The water table rose for hundreds of yards outward in every direction. The hard-packed clay slowly began rehydrating. The drainage ditches that had defined the property for decades started backing up as beaver dams interrupted their flow. Water that had always rushed toward the river now spread sideways across the land, and the vegetation responded. By July 2019, satellite images showed green coverage across roughly 30% of the land within 500 yards of active beaver ponds. It was not just grasses anymore. Willows were reaching 10 to 15 feet in height. Wax myrtles were pushing up through the ground. Buttonbush appeared in thickets. Cypress seedlings, which researchers had assumed were wiped out from the area, began breaking through the soil from seeds that had outlasted decades of drought underground. Once the beavers had real trees to work with, the quality of their dams changed completely. The crude mud and grass piles became interwoven branch and mud structures reinforced with vegetation, dams that could withstand heavy flow without failing. Wildlife began arriving on its own. By fall 2019, bird surveys documented 47 species actively using the restored wetlands, all of them absent from the area for years. Wading birds like herons and egrets worked the shallow pond edges. Migratory ducks started stopping during their seasonal routes. Ospreys claimed the tallest standing dead timber from the original forest as nesting posts. The amphibian recovery was even sharper. The 2018 baseline showed essentially no frogs or salamanders anywhere on the property. By late 2019, researchers were documenting large breeding populations across at least 8 species, drawn in by the shallow, plant-dense ponds that beavers had created. By 2021, 3 years after release, the numbers had crossed into territory nobody had predicted. The original 47 colonies had grown to 83. The beaver population was estimated between 340 and 360 individuals, more than had been released, confirming successful reproduction. The wetlands were no longer dependent on the beavers building from scratch. They were maintaining and expanding what already existed. Vegetation was dense enough to provide year-round food. The ponds were deep enough to carry water through the dry season. Aerial surveys in 2022 showed approximately 16,200 acres, representing 42% of the original site, functioning as genuine wetland. Not restored to its original 1950s condition, but transformed from an ecological desert into a working system with water retention, plant diversity, and abundant wildlife. The Alpha colony's descendants were now maintaining a dam complex that created 78 acres of wetland on their own. That single structure held back enough water to rehydrate hundreds of surrounding acres. The land nearby had shifted from bare clay to dense marsh, with vegetation reaching 12 feet high. Alligators moved into the larger ponds. River otters followed the beavers in and built their own populations. Bobcats were being photographed hunting the wetland margins. The economic picture changed just as dramatically. In 2018, the land had no practical value. By 2022, the restored wetlands were generating an estimated $4.7 million per year in documented ecosystem services. Flood control through water storage, water quality improvement through natural filtration, carbon capture through regenerating vegetation and rebuilding organic soil. Wildlife habitat sustaining both commercial and recreational species, all of it produced for an initial investment of $680,000. The conventional plan would have consumed $87 million and still been years from these results. The beavers did it in 4 years for less than 1% of that cost. By 2023 and 2024, word had spread in the scientific community, and researchers were arriving from around the world to study what had happened. What Florida had stumbled onto was a restoration method that performed in precisely the situations where conventional approaches break down. The mechanics behind it are straightforward. Beaver dams hold water. Held water grows plants. Plants supply food and construction material. Better material builds stronger dams. Stronger dams hold more water. The loop feeds itself and accelerates until it reaches a point where it no longer needs any outside support. The detail that most startled the scientific community was not the speed of recovery or the cost savings. It was that the beavers had achieved all of this without any existing tree cover at the start. The assumption had always been that beavers required established forest to function. Florida demonstrated that beavers can build an entire ecosystem from near-zero conditions, provided the release involves enough animals across enough space to establish self-sustaining breeding groups before the population collapses. Research published in 2023 measured what was happening at the soil level. Beaver ponds were accumulating sediment and organic matter, laying down layers of rich mud over the dead clay that had defined the land since the 1980s. Soil samples from 2024 showed carbon content had risen 340% near active beaver ponds, compared to the 2018 baseline. The water table had climbed 8 to 12 feet across the entire project area. Groundwater monitoring equipment recorded levels approaching pre-drainage conditions from before the 1940s. In 6 years, the beavers had undone 70 years of hydrological damage. By 2024, the species inventory was almost unrecognizable. 127 bird species documented against 12 in 2018. 34 mammal species against 3 in 2018. 18 reptile and amphibian species against 0 in 2018. The beaver population sat between 410 and 450 individuals, managing over 100 active dams. Wetland coverage had reached 8,300 acres, 56% of the original site. At the rate the expansion was continuing, projections pointed to 80 to 85% coverage by 2030. Every established principle of ecological restoration holds that conditions must come before animals. You rebuild the hydrology, you plant vegetation, you let the soil heal. Then, eventually, you reintroduce wildlife. Florida reversed the order completely, dropped animals into a dead zone, and the animals rebuilt the conditions. It worked faster and at lower cost than the standard method would have managed. The implications extend well beyond Florida. There are millions of acres of degraded wetland globally that have been written off as too damaged or too expensive for conventional restoration. This project demonstrated that releasing ecosystem engineers into those areas can achieve what traditional approaches cannot, at a fraction of the price and in a fraction of the time. The UK launched a comparable effort in 2023, releasing beavers onto degraded farmland. Australia is evaluating whether introduced beavers could rehabilitate damaged billabong systems, a move that carries controversy since the continent has no native beaver population. China is exploring applications along damaged sections of the Yellow River. The formal term for this method is rewilding through keystone species reintroduction. The plain description is that beavers are better at restoring wetlands than we are, and sometimes the most productive thing humans can do is acknowledge that and step aside. In 2024, you can walk through those 15,000 acres and find no trace of what they were in 2018. Where the ground was cracked clay, cypress trees stand 20 feet tall. Where drainage ditches ran empty, streams carry fish through the landscape. Where silence held, there are bird calls, frog choruses at dusk, and the constant sound of water moving over beaver dams. The main dam built by the Alpha Colony, which started as a 3-foot pile of mud and grass in the summer of 2018, is now a 12-foot-tall, 600-foot-long structure that would require millions of dollars in human labor to replicate. The beavers repair it continuously, closing any breach within days. The project is effectively finished. Not abandoned, finished. The beavers sustain themselves. The wetlands sustain themselves. Florida allocates roughly $40,000 per year for monitoring, but the system needs no intervention. From 2018 through 2024, total expenditure was approximately $1.1 million. The outcome is 8,300 acres of functional wetland, generating millions in annual ecosystem value, and supporting wildlife communities absent from the area for decades. Nobody expected this to work. Every credentialed voice said it would fail. But nature has been running this process for millions of years without input from ecological restoration science. Sometimes the most effective solution is to bring back the animals that shaped a place long before humans altered it, and then leave them to finish the job.